Welcome to this video for the Insights Hub Quality Prediction video series, where we will give you a detailed overview of the application and equip you with all the needed information to get started with Insights Hub Quality Prediction. In this video, we will continue our video series with the presentation of the training and the analysis of the model results for the model, which we created last time. Let's start the application from the Insights Hub Launchpad. After starting Insights Hub Quality Prediction, go to the Running Models and open the draft of the selected model like so. With this step, you should already have prepared the input data and the output quality data. Both are ready for the model training. To proceed with the training, we should select the right type of the machine learning model. The random forest can be selected as default, or also other types like linear regression, gradient boosting regressor, neural network regressor, or XGBoost regressor can be selected. For users who have experience in data science, it is possible to select their own parameters of the model. In most cases, it is suggested to proceed with the optimized version selected by the application. So let's start and proceed to the training board. The first view of the training board shows the accuracy metrics of the model. You can see the accuracy score here, which is a correlation factor between the prediction and the true results, and the mean absolute error and root mean square error. The accuracy score must be as high as possible and as close as possible to 100%. The errors must be as low as possible for a model with a high accuracy. If the accuracy score is high enough, we can proceed with the next steps and evaluate the details of the model. On this chart, we can see the correlation between the prediction and the true results. The data can be reviewed on the timeline by comparing each data point for prediction and true result for the training dataset, or as a correlation chart where you can see the prediction versus the true result. Additionally, you can review the diagram of deviations for the prediction and true results. In the Feature Importance chart, important information about the factors influencing the quality result can be reviewed and analyzed. In particular, with two methods, the importances are calculated. The importances are showing what factors out of selected inputs really influence the quality result, which parameter has the most influence, and which parameter has almost no influence on the quality parameter. In this case, these three parameters have the most impact, and the remaining parameters have almost no impact on the quality results. On this next view, it is possible to start the detailed analysis of the prediction results, true results, and the influence factors in particular. On the last two axes of this chart, you can see the true result, prediction result, and the next axis on the left side, showing the input parameters with the highest importance. In this chart, the lines connected to the prediction and true result must be as horizontal as possible, ensuring that the prediction and the true result are close to each other. And if you follow the line, you can see what process parameters were used to get this quality result. On the quality axis, you can select values representing the highest quality result, and you can see the machine settings or process parameters which should be set to achieve this high level of result. Similar can be done for the low level of result. You can see how the machine should be set to achieve this parameter. This can equally be done for the middle of the tolerance. Another question would be, what parameters can we achieve on the quality side with the lowest process duration? In this case, we would select the corresponding range on the duration side. After that, you can see what range of the quality result can be achieved with these duration settings. Basically, the user is able to analyze the machine settings and understand how this setting should look like to achieve a certain level of the quality result. A similar visualization can be done with a 3D map, where on the axis we have the parameters with the highest importance, and the color tells us about the level of the quality result at the input data. You can see the input parameters which are already available in the Result and the Data Analysis tab. The Data Analysis tab shows the distribution histograms for the input parameters and the correlation heat map between input and output parameters. In the Configuration tab, you can see an overview of the selected model parameters. Once the user is comfortable with the model accuracy, ensuring that no outliers and no unexpected behavior of the data is seen on their views, the user can save the model as a new version. Now we showed you how to create and analyze the machine learning model of the manufacturing process with the corresponding quality and process data. For more information, find further links, other videos, and the technical documentation in the description below.